Hi, my name is Angel Rodriguez, and I'm loosely associated now with the Raspberry Shake Network. And I wanted to go over how to use the Raspberry Shake Network to locate events by using Swarm. And Swarm is an integral part of the entire scheme of the Raspberry Shake Network. So just to warn you that I use Macintosh and Chrome. So I don't know how to do some of these things for Windows or for Linux. They'll be a little bit different. The first thing you want you to do is open a Chrome browser and go to the Raspberry Shake network, which should, if you go to the ShakeNet, you can go to Station View, and you can see the address up here for Station View. And that'll bring up all of the locations of where the seismometers are in the Raspberry Shake network. To locate events, you need to have a density of maybe 10, 12 stations inside a 100-mile circle. A 50-mile circle would be better. And as I zoom in on the US, you can see that this is possible in places like Southern California, the Bay Area, Seattle, Oklahoma, Baltimore, Boston, and several other places that have the density. We'll be using the 10 or so that are available in Panama. And as I zoom into Panama, and Panama because I'm in Panama and I'm more familiar with these stations than others, you'll end up with a map that looks like this. And so if you mouse over the station itself and click on it, it'll come up with the name of the station. The network name is AM. The station name for this one is RF248. This one here is RDC7A. I'll do another video on why these names are so different and so crude in a way. And R27F1. But once you find that you're in an area, and you don't have to be in that area, you can just say, I want to locate New Zealand, which has that kind of density, then you can create all these steps for New Zealand or Boston or anywhere. I tend to look at events in England and in Panama. So Swarm is going to need a file which is called a swarm metadata.config. It's not present in your Swarm directory. You have to actually create it. And I'm assuming that for your system, you know how to create a text file. Don't know how to do it in Windows. In Linux, you just open it up in a text editor and edit away. The Swarm manual has a good description of what that file needs to look like. And I'll just take a second now to go show you where you would find the Swarm manual. I generally just put AVO, which is Alaska Volcano Observatory, Swarm into my browser, and then it brings it up. And you go to the download page, and it says documentation. So the latest version right now is Swarm 2.843, and I suggest that you have that version. And when you go to the documentation page, it has the manual, and you can download the manual here. So the example of the Swarm metadata file is in 13.8 paragraph of the manual. It's called Swarm metadata. You have to follow the capitalization, that is the capital S, capital M. And you can see that it has the station name and then the channel name. And for Raspberry Shakes, most of them are SHZ or EHZ. Then where it says OP, you're going to have to put in an AM, and then longitude, colon, and it's a capital L, and then the longitude, and then the latitude, and in that format with 5 decimal places. So going back to the Shake network, when I click on a station, and this is RF248, then you click on the download the instrument file and scroll down to where it says lat long. And that is right here where my mouse is. It says latitude 8.792 and a bunch of decimals. You really only want 5 decimals. And then the longitude is minus 8268, whatever. Again, you 5 of those. So to create the metadata file, you would go to the station, you'd get the station name, you'd put it in the metadata format, you'd cut and paste from here into the format that is in the manual in 13.8, and create a file that looks like a metadata file. And my metadata file looks like this. Going to, and here it is. You can see that all these stations at the bottom have R7C3 format space SHZ-AM space 00 equal longitude, latitude, and this is what you'll have to do for the stations that you choose, and I would choose at least 5, maybe 6 or 7 would be better for the area that you're in. So in the Swarm manual, go to section 13.8 called Swarm Metadata.config, and it has to be capital S and a capital M. And it does a little bit of explanation, but then it has a sample file. What I'm going to do right now is just copy a sample of the sample file here, and I'm going to copy it, and then I'm going to open up a terminal window. For me, remember, it's going to be a Mac window, a new Mac window. Here it is. I'm going to make it a little bit bigger, and then increase the size of the text so you can see it. And then I'm going to make the file touch. I assume you know how to do this. Swarm metadata.config. And since I have 2 of them, I'm going to call this one 2. You need to get rid of the 2 at the end of the day, but here it is. And then I'm going to edit it with Nano. There it is. And I open it up, and then I'll paste in the sample that I got so that we can use it as a template. And so I'm going to leave this window in the background here and go back to the map with all the stations on it and go through the whole process. So clicking on this station here, we see that this station's name is RF248, and we'll click on the metadata on the response file area, and then I'm going to go down and cut and paste out of that file the lat long stuff, copy. Then I'm going to go back to my window where I've got the file that I'm going to edit. And I'm just going to paste it in. It's in the wrong format, but that doesn't matter right now. And since this is a text, it's Nano, you just have to do things the Nano way. So here I would put in the name of the station, which again is RF248, and it is a EHZ. And then we put in the channel, which is an EHZ. I'll show you exactly where that is. And then the station name is AM, and the location code is 00. And after the 00, you have an equal, and then the word longitude, which I will just longitude, and I'll even cut the space in. And now I've copied it, pasted it, it's there. And then from the longitude, I will take out the -82 and 5 decimal places and put it right here. And then I'll give it the semicolon it's looking for. And then the word latitude, which again I'll just cut and paste. The next one will be easier. Give them my space, and then I'll cut from here out to 5 decimal places. And that's it for the first line. And we can use this line as a template for the very next line. Going back to the map, and I'll choose the next station. This one is RDC7A. And I'll go back over here, and I'll put RDC7A. And it is an EHZ, again, EHZ. You can see that right here under the little trace, that whole name, and then it's in the AM network, 00 equal. And we're going to cut right from the colon. Paste. We have it there. And then we'll open up the instrument response file and go to the lat long, which I'm just going to cut again so that I can take them both at the same time. Go here and paste them here so that I can do more cut and pasting. And so the longitude is minus to 5 decimal places. I copy it. I move my cursor up to here, paste it, semicolon, and then I'll choose the latitude along with the colon and the space. Paste it, and then I'll find my latitude, and I'll cut and paste it from here. 5 decimal places. So we got it. You'll make as many of these as you want, because the more the merrier. And then of course you know how to get out of Nano. It's Control X, yes, and it's saved my file. And now I'm just going to cat the swarm metadata file so that you can see what my file looks like. And there it is. Well, what we're going to do now is show you in Swarm what an event looks like and what the concept of the P and the S look like. P is the primary, S is the secondary, and then we'll also be picking something called a coda so that we can calculate a simple magnitude called a duration magnitude, which is pretty equivalent to the Richter magnitude. And so I'm going to open up my Swarm, which I have here. And the way you do that is you go to the Swarm folder, and I'll just close this out. And I come up with /swarm/sh. Like I said, I'm doing this in Macintosh. This is the same for Linux, and I don't know how to do it in Windows. And so we'll bring the program up. And then you have to look at the Raspberry Shake CAPS server. And I'm going to highlight it here and then look at the configuration of it. And I've called it the CAP Shake Data, and it's located at caps.raspberryshakedata.com. You can see that right here. And the port is 16022, timeout 15 seconds is fine. So this contains all of the data with a 30-minute delay that's introduced into it. So you can't see things for half an hour, but no big deal. Then I'll open up my CAPS and I'll go to the network. And then we're going to look for stations in Panama. And the first one I'm going to look for is R27F1. So the 2 is the first number, 2, and then I'm going to look for the 7. And then F is at the end of them, and here it is. And I'm going to open it up. And I'm going to choose 5 stations here. There it is. And then I'm going to look for RF248. And then the F is way down here. In another video, I'll explain why these names are like the way they are. So now I have the 5 stations I'm going to use, and on each one of them I'm going to turn down the little slider bar just to get a little bit of the noise out of the way. So I've got the noise turned down a little bit, and then I'm going to go to the Windows and say Tile Helicorders. And here it's tiled them for me. They've put them side by side, and at this point I'm going to click on Save Layout, and I'm going to call this Demo 5 Stations. And now what happens is, and I'll show you the way it's listed there as Demo 5 Stations. I'm going to close these just for fun. So when you open your Swarm up, you can then just go to the layout and click on Demo 5 Stations, and it'll bring them up and tile them for you. That's HelpSpot. So this was about a PNS thing. The primary wave, when the earthquake happens, all the energy comes out from the same point, obviously. And the primary wave is a compression wave. It's as if you hit a hammer on the end of a bar. And that compression wave would travel all the way through the end of the bar. And then the S wave follows it. And it's like as if you wiggled a string. And it's slower. So as you're further away from the station, those things separate out. And I'm just going to choose an event that's easy to see, this one here. And I'm going to make this station big right now so we can see this a little bit better. And here is the event. The primary wave is the first one, and in Z channels, that is the vertical channels, the S wave is not so apparent, but it would be right around this area. And we'll talk about that a little bit better in a minute. So I'm going to tile this again just to go back to where we were, and then pick that same event for a different station. And again, I'm going to bring it up a little bit so that you can see it better, look at the traces with more traces in it. And here we are. We can see the primary wave, and somewhere in there the secondary wave. And so to locate an event, we need to pick maybe at least one S, and we can even take a guess, and all the P's and the codas. And I'll go through how we do that. But finding an event, identifying an event is not always easy. Here's another one. And then I'm going to zoom into this one. Here's the P right here, and you could guess that the S is here. It has a higher amplitude, and you know, picking the S on the vertical channel is always sort of a guess. So I'm going to go back to tile the windows to assemble them again, and go to another station to look at the same event. And actually, the S is pretty clear. It's right here, and the P is here. But we'll go into the next part. So what I wanted to say is that the primary wave is the one you see first. The secondary wave comes a little bit later, and then the coda is picked where the event is ended. And so that would be where it sort of looks like where it was before the P. And we'll be picking those to save some of the confusion. In the next video, we're actually going to bring up the swarm and bring up the 5 stations and show you how to do the picks, and then show you how to do the locate. Now we're actually going to go through the process of locating an event using 5 stations in Panama. We have a layout for the 5 demo stations, and here they are coming up. So we're going to pick with these. And so what we have to do is select the event and then put it in the clipboard. So the clipboard will contain the event, because we'll be picking the event from the clipboard. Swarm has a particularity that as you're picking many things on the clipboard, it scales them all in relationship to the last scale. So I'm going to pick this station here, R78EC last, because it sort of looks the best. So I'll start from this end. And I'm going to zoom out so that we see more of it with the little negative thing, and even zoom out a little bit more. And then put it on the clipboard. And it's a little icon right here next to the one that looks like a bunch of little circles. And it looks like a clipboard. So then I'll close out the clipboard and go to the same event in this station. And I will zoom out again so that we have the whole event and part of the coda. And that just certainly doesn't look great, but it's what we got for that station. So I'll put it on the clipboard. And I'll close the clipboard again and go over to this station. It looks great on this station. And I'll zoom out again just to make sure I have it all. Pick it over a little bit so it's sort of centered. There, onto the clipboard, and then I'm going to pick it over here in this station and zoom out. And I see it there fine. It's on the clipboard. And so now I'm going to close the clipboard again and go to this last station, which is where I think it sort of looks the best, and zoom out. I have it all onto the clipboard. And now I have 5 stations in the clipboard, and they actually look reasonably well. The picking process is you have to pick where the P arrived and where the S arrived, and you have to pick the coda, and the coda is the end of the event. So if you look at the top one here, you can see that the coda would be around here, because this is about where the trace looks like it did before the P. So it would end there, and we use that coda to calculate a very simple magnitude, which is called a coda magnitude, very equivalent to a Richter magnitude. So the P and the S, when the event happens, start at the same time. The P is a compressive wave, and it's the kind of compression that would go through a steel rod if you hit one end with a hammer. You would get and you had that rod against the wall, the compression would go all the way through the rod to the wall. And the S wave is a transversal wave. It's more like wiggling a string. So P waves travel through water, S waves don't travel through water because they don't shear very well. And so it takes a while to figure out where those are. And I will actually be honest, in the Z channel, that is the vertical channel, in an ideal Z seismometer and in an ideal world, you'd never see the S because it only records verticals and the S waves are horizontal. They always have a little bit of a vertical component, and that's why we sort of see them. But picking them is kind of hard. So that said, you'll find a little icon up here that looks like a little triangle, little top, little wedge of the earth is what I think it is. And then it comes up and it says pick menu. And so now the pick menu is active, and we'll go to the first one, and I will pick with the right button, pick the P, and it says pick, P, and I'm just going to pick all of these impulsive because that's generally what it is on the Raspberry Shake network. Then the question mark is because I don't really know if the first arrival was up or down, so that's what the plus and minus are. And then I'm just generally pick 2, which is a weighting factor of how good you think the pick is. So we're going to go all with middle picks, question mark on the direction, impulsive, and then the P. So now that's been picked. And I can actually see that it's not picked very well, but for this, it doesn't matter. And then the S, I don't know where the S is, so I'm not going to pick it on this channel. And then the coda is around here, right button, pick C1, coda 1. And then we'll go to the next station, and we'll pick the P right here, pick P, impulsive, question mark 2. There's my P. And in this one, I'm going to take a guess. I'm going to guess that the S is right around here. And that just comes from lots of years of looking at these things. It really is not easy to see. So it would be pick, S, impulsive, question mark 2. And I'm going to pick the coda right around this little bit here, right where I'm at, because it looks like a little bit right over here. So this is where I'm going to call the event end and pick C1. Go to the third trace. I didn't pick it. Pick C1. There it is. And the third trace, pick impulsive P, question mark 2. You go through this process as many stations as you're going to use. I'm going to not pick the S because I can't really see it. I mean, I'm sort of guessing it's around here, but I don't know. And then the coda I'm going to place right around here. Pick coda 1. And then I'm going to pick here the P, pick it, impulsive, question mark 2. I'm going to pick the S right here, just because it sort of looks like it's there. S, impulsive, question mark 2. And I'm going to place the coda right around here. Pick coda 1. And I'm going to go to the fifth one over here and pick the P here. I'm going to pick the S right here because I think I can see it. And I'm going to pick the coda right here. So now you can see that I have 3 S's, 5 P's, and 5 codas, and that's really enough information to do the picking on this. And I want you to remember that this is going to send the information of the picks and the traces to a program called Hypo 71. Hypo 71 was written in 1975. Most of the physics still matter, but it does things in a sort of a funny way because it was written in Fortran. And so when you see the output of this, your 5-character station's name will be truncated to 4 because that's all Hypo could understand, but SORM is done away and they dropped the last one. So I go up and I pick on the menu, I open up the event dialog, and I hit run. I get 5 stations, and boom, location is 877 minus 82. And the one thing that I know for sure is that this is not a great location. And to start with, the Raspberry Shake network takes all of the lat longs for the stations and skews them off to the side so that you can't drive straight up and get one. And then you can see here the velocity model is a default velocity model. I mean, the people here put a velocity model for the entire world for your swarm, and the velocity model tries to tell at different depths what the velocity of the PNS should be. So they have a 4-layer model here that doesn't fit anywhere, I'm sure. Los Angeles has a different one than San Diego a different one than Panama. And so for certain places on Earth, like in Britain, you can actually ask the Geological Service for the velocity model and they'll give it to you, and then you can add it here and that will make your locations actually more accurate. So that's it. I will go into more details of what's on this menu here and how to do plots and other things, but basically this location is probably within 2 to 5 miles of where the event really happened. With a little bit of care in the picking in the S, you could get down a little bit, but remember that the locations of these stations have been skewed by the Raspberry Shake network, so there's a lot of pluses and minuses, but it's pretty good. Thanks for listening.